Hello everyone, this is section 7.3 for pre-calc, and in this section you guys are going to be solving systems involving 3 equations with 3 different variables. Not that we need to emphasize this, but what you guys are going to be doing is, if I reference back to what you did yesterday, this was an XY plane, and you were taking 2 lines and wondering where the lines crossed, and your answer was an XY coordinate. Well, this was 2-dimensionally. This is 3-dimensionally. XY is the normal XY plane you're used to, and Z goes vertical. It would like come out of the piece of paper at you, okay, or go below the piece of paper away from you. So that's a vertical dimension, where these are a left and right dimension. Okay, not that that's crucial for understanding this, I'm just letting you know what this is. And you write your answer alphabetically, so it's X, Y, Z. All right? When your problem is given to you that looks like this, where you know what one of the variables is, it's called back substitution. You're going to substitute it back into a previous question or a previous equation. Whoops, I didn't do the actual substitution. Yikes. Times what Z was worth, 5 is equal to 13, and then solve for Y. So Y would be equal to 3. So far you know Z is 5, Y is 3. Now all we got to do is find X. Well, you know these 2 variables, so you could fill them in for Y and Z in this equation and be able to solve for X. So it's called back substitution. You're just working backwards until you finally get up to the 3rd variable. One like this, or on the next page that looks like that, or on the next page that looks like this. Your goal is to make it look like what you guys did yesterday, where it was 2 different equations with only 2 unknowns. And then you either solved by linear combination or you solved by substitution. Okay? So how do you do that? Well, in looking at these, how about I take this center equation and I'm going to multiply this center equation by 2. So the top one stayed put. The middle equation now becomes negative 2x plus 6y, let's see, minus 10z equals 8. And the bottom equation stayed put, 2x minus 3z equals 0. Okay, if I were to add the top 2 equations together, this would cancel out. I'd have 4y plus, or how about minus, because I didn't look far enough ahead. This would be minus 7z. Whoops, I'm not being very thorough here. Minus 7z equals 13. Now if I combine the bottom 2 equations, I get 6y minus 13z is equal to 8. And now it's just like this page, where you have 2 different equations in the same 2 unknowns. So now that you have this combination, and I did that again by combining, say, the first 2 and then the middle and the bottom 2, so I got the same 2 variables in the equations. Okay, I eliminated the x's, so I ended up with y's and z's. Now I solve this just like before. You're first going to find y and z, which then will allow you to find the x value by filling y and z back into the original equations. Okay? In the interest of time, I'm going to let you guys work through that. I don't think that there's anything that's going to be surprising that happens here. I'm just trying to lay out the strategy of what you do. So for one like this, it's the same idea. The hardest part is just going to be looking at it and deciding, well, which combination am I going to choose? Which variable would I like to get rid of? Looking at this equation, I already have an x and a z. So I have a 2x minus 3z is equal to negative 14. If in this top equation I could get rid of the y value, then I'd have x's and z's. Oh my goodness. Okay, football players are a little riled up right now. So if I take this top equation and multiply it by 5, I get 15x minus 5y plus 5z is equal to 5. Sorry for the interruption. I took 5 and multiplied it through the top equation. The bottom equation is 5y plus 2z is equal to 8. If you combine these two equations now, you get 15x, those cancel out, plus 7z is equal to 13. And if I write that with the original middle equation, you can see I now have, the same variables, two equations, two unknowns, and now I do this just like we did back in section 7.1 and 7.2. Okay? Again, in the interest of time, I'm going to let you guys handle that. When you guys do the solving for this, you're going to find x and z, and then you're going to fill x and z back into the original equations to be able to solve for y. Okay? So, the third type looks like this. The other two that you had were always missing something. Like this one was missing an x, that one was missing a y, this one was missing, and we did the back substitution. Sorry, I wasn't very clear when I said that, but you're going to do back substitution. This one was missing the y, and you went through the strategy how to do it. Some kids get a little intimidated when nothing's missing. Well, you still approach it the same way. It's your judgment on what variable you want to make go away. And looking at it, I kind of like making the z's go away here. Say I were to take this bottom one and multiply the bottom all by -1. So this equation isn't here anymore. I've got this one. Now if I combine it with the middle one, 6x minus 5x is x. 2y and 1y make 3y. Positive z and minus z are gone. 10 minus 15 is -5. Okay, so that's one pairing. And I have to do another pairing to get rid of the z's. So how about these two together? I could do it with these two. It doesn't matter. I'm going to choose to do it to these two only because one's, I don't know. I guess I don't know. I don't know why I'm going to do it to those two, but those are the two that I'm choosing to do it with. Okay, whimsical, I guess. How about that? Because it truly doesn't make any difference. I need this to be a 5, so then I'm going to take this entire equation and multiply it by 5. So I have 30x plus 5y minus 5z is equal to 50. 32x gone. Oh, that worked out nice. And here I get, so that would be 32. So x is equal to 1. If x is equal to 1, I could fill it into this equation right here. 1 plus 3y is equal to -5. Subtract the 1. Y is -2. So now you know these two, and you can fill it back into x and y and solve for z. There you go. Thanks for your patience. Come on.